So imagine this. You grab your device, open an app, do some doodles midair. Watch your art appear on the screen. Is this the future? No, it's right around the corner. And when you get to learn to build something like this, you will call all of this amazing. I am Princiya, and I love JavaScript. So, I am from Bangalore, and I work for an education startup called Guruji Learning Labs. I work on Node.js, building backend solutions. I participated early morning today in this JS party. I was not sure because it was before my talk, and I was already nervous. But yes, thanks to y'all, lovely audience. I think I just got lucky. Okay, so the way we interacted with computers on a large scale was stuck in place for roughly 20 years. From mouse to keyboard to joystick, it is game over. Today, it is the era of gestures. Today's gamers can do everything from slice and dice in Fruit Ninja to quest for a dragon in Skyrim. From these early successes in 3D gesture-based input, we now see high-growth market emerging across multiple industries. So this is what I am going to bore you all with for the next 30 minutes. So by the end of this talk, perceptual computing, augmented reality, virtual reality will no more be alien to y'all. Any technology enthusiast can start getting their hands dirty with these latest cool technology. You get to learn to build the next generation of natural, immersive, intuitive apps, hands and finger tracking, facial recognition, gesture analysis, 3D scanning, the list goes on and on. Now let me tell you the best thing. You wouldn't need a hardware, that is a 3D camera or a motion sensing device, to test out the SDK or to build a hello world sample. I shall tell you some secret to test the SDK merely through JavaScript. Go and sculpt 3D objects, explore outer space, or gain some magical powers. Okay, so let's get into the basics for this talk. 3D camera, a type of camera with 2 or more lenses with separate image sensors or film frame for each lens. 3D cameras give you the visual ability to perceive the world and the distance of an object in 3 dimensions. Perceptual computing, ability for a computer to recognize what is going around it. More specifically, the computer can perceive the environment and the users in that environment. Augmented reality, direct or indirect view of a physical, real-world environment whose elements are augmented by computer-generated sensory inputs such as sound, video, graphics, etc. Here, a view of reality is modified by a computer. As a result, the technology functions by enhancing one's current perception of reality. By contrast, virtual reality replaces the real world with a stimulated one. Augmentation is conventionally in real time and in semantic context with environmental elements. So, we need to know more about these motion sensing input devices. Here are the few ones which I have tested out for the SDKs. Statutory warning here, these are just listed in alphabetical order. I am not representing any of these companies. So perceptual computing, augmented reality, virtual reality isn't new. Devices like these, Intel RealSense, Leap Motion, Microsoft Kinect, have been around for a while. You can control these devices with a wave, a wink, swipe, and a smile. With these, you can scan real-life things like a piece of art, a child's toy, or your own face and create a digital 3D version. The technology behind these is around a webcam style added as a peripheral device. It enables users to control and interact with their computer without the need for a game controller through a natural user interface using gestures and spoken commands. These devices feature an RGB camera, depth sensor, and multi-array microphone. This technology could vary across devices because Leap Motion doesn't support voice or facial recognition. Kinect and RealSense does. So let me tell you the motivation behind this idea. Few months back, I was preparing for my talk on perceptual computing, and I was supposed to give a demo on Intel RealSense JavaScript SDK. This SDK works only on Windows. 2 days before my talk, Windows in my laptop crashed. Yeah, I did not have a backup of this code, and panic mode turned on. This is when I thought of this web simulator. By the way, when I was preparing these slides, I used Google Docs. I didn't want any sort of laptop mishaps happening in a foreign country. I also thought it would be nice to conduct workshops, seminars for a larger audience who would be intending to learn a new technology but wouldn't be having the required hardware, say a RealSense, Leap Motion, or a Kinect. That is where this web simulator is very helpful. When the idea clicked, I started wondering, how is it that an external motion sensing device interacts with the computer? Natural question. All these 3D cameras are connected through a USB port. And the 3D camera SDKs access the 3D camera through the USB port. Okay, so far so good. We have one thing in common, that is the USB port. Now all these SDKs have another thing in common for web applications, that is JavaScript is the primary language, and in addition, there is another thing common which is used to transmit the data from the camera to the computer, and this is done using Websockets. So this is my secret. These SDKs create a WebSocket which is part of the whole application, and the secret behind this simulator is creating a Node.js-based WebSocket server which replaces the default one used by the SDKs. That's it. That's the secret. So for my simulator, I create a Node.js WebSocket streaming server and replace it with the default one which is used by the SDKs. Let's try to understand what a WebSocket is. The explanation might seem too technical, so to put it simple, data can be sent between client and server. The WebSocket specification was developed as part of the HTML5 initiative, and this introduced the WebSocket JavaScript interface. Here is some code for a WebSocket implementation. To connect to an endpoint, just create a new WebSocket instance, the first line there, providing the new object with the URL that represents the endpoint to which you wish to connect, as shown here. One thing to notice here is that, to whoever is new to WebSockets, a WebSocket connection is established by upgrading from the HTTP protocol to the WebSockets protocol during the initial handshake between the client and the server, which is why the URL begins with a WS and not with a HTTP. For secure, it would be WSS. Before connecting to an endpoint and sending a message, you can associate a series of event listeners to handle each phase of the connection lifecycle as shown here. So we have a bunch of event listeners like on open, on message, on close, on error as well, we can include that. Now to send a message to the server from the client, simply call send, the last code snippet here, and provide the content you wish to deliver. After sending the message, call close to terminate the connection. As you can see, it really couldn't be much easier. Just do this Websocket implementation and we can test out the 3D camera SDKs. So I have uploaded the code here and I will share my slides shortly. The last Windows crash did teach me this lesson, and since then, whenever I've been working, I make a backup. But my GitHub reputation is quite bad. I am sort of a new one to the open source contribution. Yeah, I have told myself that I need to be active and do more sort of these contributions. So coming back to this code, I have working demos uploaded for RealSense and Leap Motion, and I'll upload the code related to Kinect shortly. So to pick a few code snippets, which could be the starting point for you all to get started. Couple of things here. Each SDK has its own comfortable ways of receiving data. Leap Motion, what it does is, captures the frames from the controller, writes the JSON data to a file, and sends this JSON output over WebSockets. So the JSON data is pretty big, and it looks something like this. It's a huge one. So Leap Motion, what it does is, captures the frames from the controller, the Leap Motion controller, writes this JSON data to a file, and sends this JSON output over WebSockets. So Leap Motion expects a pre-processed JSON input, whereas RealSense, on the other hand, expects the raw image frames over WebSockets. The SDK then processes this data and performs facial gesture recognition algorithms, which are part of their SDK. The difference to be noted here is that Leap Motion expects the WebSocket server to process the raw data and generate meaningful JSON output like this, whereas RealSense takes only the raw data from WebSocket and the SDK then processes this raw data. The complex facial gesture algorithms are part of the SDK, independent SDKs. So this is from RealSense.js file after you have downloaded the RealSense SDK. So you can search for socket in the file. You can search for the keyword socket in the file, and you'll find something like this. So here we have socket URLs, which is an array, and it tries connecting to these bunch of WebSocket URLs. This is how you make a WebSocket server call, as we already discussed. So instead of HTTP, it would be a WS, and then you can associate any port number. The last few lines, I have shown you all the WebSocket methods and the event handlers. So this is exactly what appears in the SDK. On open, on message, on error, on close. Special thing to note here is binary type, which is set to array buffer. This needs to be done for WebSockets when you send raw data, because the RealSense expects the raw data over the WebSockets, which is then processed by the SDK. This is what you'll get from Leap.js after you've downloaded the Leap Motion SDK. Pretty much similar to the previous one, except the data comes pre-processed, that is in JSON format here, and no array buffer setting is needed for WebSockets. So as I told, this could be the main difference while trying out the different SDKs. The RealSense expects raw data, which why you'll have to set the array buffer type to binary, and the Leap Motion uses the JSON output, pre-processed JSON output. So this is how you write a Node.js WebSocket server. Now, after Node.js put JavaScript firmly on the backend, and AngularJS made us realize that business logic needs to be moved entirely on the client side, possibilities for JavaScript were endless. JavaScript phones, robots, and whatnot. Here, a Node.js-based WebSocket server has been implemented for this web simulator. The port number, as you all see in the second line there, is changeable. We need to replace this value with the port number used by the SDK. So the Leap Motion default, the port number was 6437 or 6436, or Intel's RealSense, it was the 5-digit number. The clients array represent the SDKs when they connect to this web server. This is a client-server model, so wherein this server is written in Node.js, and the clients are one of the 3D camera SDK. So the architecture looks something like this. It's a client-server architecture, wherein the server is this Node.js WebSocket server, and the clients could be the SDKs, plus it needs to be one of the browser, which actually detects the native camera. Now, in HTML5, we can access the native camera using getUserMedia. And so once you turn on this SDK, so the server will be listening. It's a Node.js server. And you open HTML browser, wherein you have some code, which will be the client, which has the getUserMedia, which captures the user frames, which captures the frames from the native camera, and then transmits this binary data for RealSense, or processes it as a JSON and sends it to the WebSocket server. So since this is a client-server architecture, this camera client sends data to the WebSocket, and this WebSocket in turn sends this data to the client, to the next client, which is our SDK. That is, it could be the RealSense or the SDK. So that's all. You capture the input from the native camera, process it, and give it to the SDK. So once these SDKs get the data, it's now quite easy to test these SDKs, go through the code, do some manipulations, use some gestures, or use some keyboard controls instead of gestures. One thing is, this simulator right now doesn't replace the whole hardware simulator. That is, it's not able to identify depth. But if somebody gives you what exactly the depth information comes, we can just tweak these values, and then maybe like we can build some other application, say gesture control, nod your head, or like wave and then change PPTs, or do some cool animations on the slides, and so on. That is exactly what Leap Motion or the RealSense does. So now coming back to my code, I need to assemble all the code and make this as a universal simulator. Right now it's 3 different versions sitting for like RealSense, Leap Motion, or Microsoft Kinect. Lastly, you can go and sculpt some 3D objects, explore outer space, and gain some magical powers. I still have some time. And if you all have any questions, you all can ask me. I would be happy to answer here, or I could take it offline, show you the demo, what I have. You could also tweet me at Princiya. I would thank JSConf.Asia for giving me this wonderful opportunity to come here and present here. I hope I didn't bore you all. I was not sure what's to be shown on the slides or how much of the demo needs to be shown. So just to prevent any sorts of mishaps, I don't have a working demo, but yes, I have a working demo, but I've not included part of the presentation because the gestures were like getting too awry when it came to the light. But yes, I have some cool gesture-based demos or like swiping-based demos. You all can come and check it out. I'll be present here today, tomorrow. Please come and feel free to bother me. I would love to. And yeah, any questions?
Thank you, Princiya. Thank you so much.
So.